So we talked about the concept of G's last day. I went on my rant that it's not a G-force, it's an accelerations. I'll just call it G's. 1 G is 9.8 meters per second squared. In 1977 in Northamptonshire, England, David Purley's race car crashed and his speed dropped from 174 kilometers per hour in 0.66 meters. I'm going to stop right there. What don't I like about that? Okay. Now, if this was in kilometers, then I could probably keep it in kilometers and in hours. I'm going to convert everything to meters and to seconds. So how do I go from 174 kilometers per hour to meters per second? Which is what? I'm going to do it on my calculator, and I'm going to just store that number on my calculator. So I'm going to go 174 divided by 3.6. And I get 48.33333, and I'll just leave it there staring at me and come back to it. He had 29 fractures, 3 dislocations. His heart stopped 6 times, and he had permanent injuries. He was never the same, but he did survive. This is, as far as we know, the largest number of G's on record. So this question is asking you to find the number of G's. What do we actually have to find first before we can change it into G's? Yep, you're right. Acceleration. So let's go with our standard method. Let's go A equals question mark. Now, eventually, you will get good enough that you can probably even stop always writing out the data. You'll just see it all. But what I am going to say is, if you're ever stuck on a question before you come to me to ask for help, if you haven't done this defix step of listing all the data, I'm not going to bother helping you. In other words, if you come to me with blank paper, no, we can get beyond that. That 170, oh, you know what else I'm going to do? I'm going to cross that out, and I'm going to say 48.3 meters per second. That 48.3 meters per second, what's that? It's a velocity. Yeah, which one, initial or final? How do you know it's initial? What's final then? Oh, stopped? Okay. So VI is 48.3. I'll write that, but I'll use my answer button to get the 3333333. VF is 0. What's that 0.66? So just putting this into perspective then, he was doing 174 kilometers per hour. He came to a stop in about that distance there. That's about 0.6. No, actually be shorter. About that, which is crazy. Okay, that's a distance. Technically a displacement, but we're not too worried about that. It usually takes care of itself. Which equation? Which equation? Don't waste my... Oh, sorry. What? I was going to cut you off because I thought you were going to read the original, but you're already getting the A by itself, and that's what I'd love to see if we can move to now. And if you're not there yet, I think I said to you last day, if you're still struggling by the end of the week, then you want to shift not into panic mode, but into concerned mode. VF squared. Well, minus VI squared all over 2D. VF is 0, so I guess I could have just said 0 squared, or I could have just said negative VI squared, but usually I'll keep the algebraic version going for this one. So it's going to be 0 squared minus, I'm going to write 48.3, but I'm going to use my answer button, and this is the day you all want to figure out where your answer button is. Most of you, your answer button is either second function equals or second function right next to the equals. Or if you're a TI, it might be alpha button equals. Or a sharp might be alpha equals. You want to figure out where your answer button is. Is this a fraction? Is there more than one thing on the top? Yes and yes. So Serenity, it's going to be 0 squared minus answer button squared. If you can't find your answer button, oh, and there's 2 things on the bottom, so brackets around the bottom, 2 times 0.66. If you can't find your answer button, now is the time I'd love you to ask me so that you know where it is. The answer button is less typing, it's more accurate, it's less error. It's one of the few triple wins we have. Y'all got it? Are we going to get a positive acceleration or negative acceleration here? Is that going to freak me out? No. He's definitely slowing down. And I get, negative, you know what? We're going to round up for him. Negative 1,770. He's earned it. That's in meters per second squared. How many G's is that? How do I figure out how many G's this is? And I will, on a couple of questions on your test, ask you to convert an acceleration into G's because it gives us a context for how big this is. How do I change meters per second squared into G's? Divide by? Okay, so now I'm going to go G's equals negative 1,770 divided by 9.8. Once again, Kieran, I'm going to use my answer button. As far as we know, this is the highest that was ever, at least that we have video data of that we can analyze. This is the highest number of G's a human being has survived. And I'm going to round up to 181 because he's earned it. And the unit for G's is G's. Technically, there's no units because the top is meters per second squared and the bottom is meters per second squared. And so meters per second squared divided by meters per second squared would cancel. So G's. Okay. Let's talk about free fall. Have I mentioned lately I jumped out of an airplane? When an object is falling through the air, in physics, we say that is in free fall. And we are going to ignore air resistance. If we start bringing in air resistance, the math gets really, really yucky. Air resistance is really tricky. How many of you have ever held your hand out of the window of a car while you're moving, while you're driving? Hopefully while you're in the passenger seat. Yes? Okay. As you speed up, what happens to the force of air resistance? It gets bigger, so it's a changing force, and that means it's a changing acceleration. And I told you at the beginning of this unit, we can't handle a changing acceleration without calculus. And also, how many of you have done the where you turn your hand sideways and you kind of fly it a little bit while you're doing that as well? So it doesn't just depend on how fast you're going, it depends on what we call the cross-sectional area. If I tilt my hand like this, less air resistance. It's all solvable with calculus. We don't have calculus, so we're going to pretend anytime we're dropping an object, we'll pretend that it's really aerodynamic and has no air resistance whatsoever, okay? I'm not going to repeat that speech anymore. In free fall, acceleration is always negative 9.8 meters per second squared. 9.8 is the magnitude. The negative is now I'm starting to say, let's let down be negative and up be positive, just so we have some kind of a frame of reference. That does change in other places. We can calculate how big this is. That number there depends on the mass of the planet and the radius of the planet. So before we landed on the moon, we had calculated what G on the moon was. It's about 1.6. We had to know that because we had to know how strong to build our rockets to land on the moon. Before we sent Mars rovers, before we sent rovers to Mars, we calculated what G was on Mars. So G on the Earth, near the Earth's surface, is negative 9.8. It actually varies a tiny, tiny bit, and it's actually negative 9. The average is negative 9.7981, which we round to negative 9.8. But there is a tiny bit of variance depending on whether you're going over solid rock, which is denser, or whether you're going over something else. NASA has satellites that are so sensitive that they can detect that tiny variance, and that's how they find large underground bodies of water. Gravity isn't quite as strong from the water as from the rocks. Little nerd trivia. Put your pencils down. Look up. I like example 2, I like example 2, I like example 2. Example 2 is a nice question. A cannonball is dropped from a cliff and it hits the ground 10.6 seconds later. Everybody right now, can you all underline the word dropped? That's going to be one of our physics trigger words. Serenity, what does part A want me to find? Which variable in our 4 equations do you think would be height? Speed? Velocity? I don't know. Which variable do you think they're actually asking me to find in my equation when they say how high is the cliff? Yep, let's go D equals question mark. Technically displacement, I think, but whatever. And then this is why I said underline the word dropped. I said anytime I use the word dropped, we know that VI is what? I will never tell you that again. So from now on, if I say we're dropping an object, you can right away say VI is 0. And the other thing we can fill in that I don't need to tell you is if we're in free fall, if we're dropping an object, we know the acceleration. What's the acceleration as a number exactly? Give me a direction showing me down, please. So those two won't appear, those two pieces of information, Julia, won't appear in the question, but I'm hoping they're kind of, yeah, self-evident now. What's that 10.6, Serenity? What are the units next to that 10.6? So? I'm looking for an equation that has d, vi, a, and t in it. Which one? Did you hear what he said? You're spoiling a lot of my punchlines. I need to get you to wait, because normally someone says d equals vit plus a half at squared, and then I say to them, oh, you wasted my time. What's vi? So what's vi times t? And so if you write d equals vit plus a half at squared, Jimmy, I will give you full marks. But I love the fact that you said, you know what? It's just going to be d equals a half at squared, or I'll write that as at squared over 2 and just not even bother putting the 1 in front because it's not going to make a difference to this particular equation. Okay? And this is why I said don't try and memorize every equation, because this is a special subcase of a sub. Learn to derive these. What are we trying to get by itself, Serenity? What are you trying to get by itself? Don't overcomplicate it. Yeah, that's why I always write that so I don't forget. Where it is. Yay. What was A as a number exactly? T, 10.6. 10.6 seconds of free fall, don't forget the squared, is a long time. This is going to be a very high cliff. All over 2. What do you get? And this is where, again, you want to practice on your calculator once you write out the numbers. Don't blurt out an answer just yet. Do this one in your head, Mr. Dueck. Well, it's roughly going to be it's going to be around 500-ish. Oh, no, it's going to be negative, first of all, is it not? What's the negative telling me? And this is why I said to you, this equation is giving us a displacement. Did we end up above from where we started or below from where we started when we dropped this object? The universe is telling you, hey, I know you ended up below from where you started, and so I kind of like the fact that that negative shows up. It's reassuring to me. What'd you get? Can you give it to me to 3 sig figs? Negative 550 somewhat. To 3 sig figs would mean one more digit, not to 4. Negative 5, and I want one more digit and round it off properly. It's a 1? That's what I was trying to get at. If you wrote more than that, I'm not taking marks off, but my default is usually 3 sig figs. Now, a height is technically a scalar, and so we don't say that cliff is negative 551 meters high. So if you didn't include a negative in your final answer, Jimmy, I wouldn't freak out. But I like the fact that we are getting a nice vector displacement here. Oh, yes, I am looking down, and it ended up below me. It's a kind of a reassuring, I probably did this right. B. Sky, when you're done yawning, what's B want me to find? Which one? What? What is VI? What's VI? Look up. What's VI? 0? Oh, did you say that? I didn't hear you. So it's asking us to find VF. And that's how I would put it together. I would say, well, VI was 0. A lot of students want to say that when you hit the ground, VF is 0. It is not. Don't believe me? Do a belly flop onto the cement. I assure you it will hurt. If V final was 0, it would not hurt. It's 0 after you hit the ground and come to a stop, but that's never what I'm talking about here. I'm talking about the impact velocity. Okay. How? Sam, which equation can I use? VF equals AT. Why didn't you say VF equals VI plus AT? Okay. By the way, when we hit the ground, what direction are we traveling? Be obvious. When we hit the ground, what direction are we traveling? Down. Am I expecting a positive velocity final or a negative VF? I should get a negative VF, and I think I do. It's going to be negative 9.8 times 10.6. Now, suppose I gave this to you as a test question. Another way that you could find VF, maybe if you wanted to, is use D equals bracket VI plus VF close bracket over 2 times T, and you would use your answer from part A. I just wouldn't do it that way if I could avoid it, because I would never use an answer to find an answer if I can avoid it. You could also go VF squared equals VI squared plus 2AD and find VF that way, but I would absolutely do it this way. I get negative 103.8. I'm going to go negative 104, which is pretty fast. And don't forget the units, meters per second. Okay. What else can we do? Next page. I don't just have to ask you to find the velocity at the bottom. I can ask you to find the velocity anywhere. What's the velocity of the cannonball after 3.6 seconds? Campbell, what's this question asking me to find? Velocity. Which one? Yeah, because what's VI if I dropped it? Now, the fact that we've just changed the time to 3.6 seconds, I am going to relist my data. So I'm going to go VF equals question mark. I can still use the VI of 0, I think. I can still use the A of negative 9.8, but I don't want to write T equals 10.6. What do I want to write instead? T equals 3.6. Otherwise, it's the same question that Sam just did. I'm looking for an equation that has those in it. Which equation? First of all, do you have your green sheet out in front of you? Okay, when I kept saying is your green sheet not here? Oh, you're going, okay. Which equation? I think it's just VF equals VI plus AT, is it not? Except you wasted my time. What didn't I need to bother reading out? So I'm going to write VF equals AT. And you'll notice I'm putting the vector symbols back in because now direction is playing a more important role. Negative means down or below if it's a distance. Positive means up or above if it's a distance. So after 3.6 seconds, it's traveling at negative downwards, 35.3 meters per second. And I can tell you this, what did I say, 35.3? I can tell you the velocity at any point in its freefall path. If we're ignoring air resistance, which we are. That's why I think I made it a bowling ball, which would have very little air resistance anyways. Pretty aerodynamic. Jordana, what's D you want me to find? I was hoping you would say D wants me to find D because I set it up that. Anyways, that's okay. Yeah, distance. By the way, we're actually going to find a displacement. Are we after 3.6 seconds? Are we above or below from where we started? We're going to get a negative answer, and I'll expect that. When will we get a positive answer? Later on, we'll start throwing objects up into the air while standing over a cliff, and so for part of it, it will be above us on the way up, and then for part of it, once it falls past us and starts heading below, it will be below us. And the nice thing is the displacement equation will take care of it all for me. I won't need to worry about what the sign is. It will take care of itself. Meanwhile, D equals question mark. It's 3.6 seconds, which is the same as part C. So I'm going to be lazy, Jordana, and not relist my data because it's sitting there in part C on the same page. Which equation, kiddo? Yep. It's going to be negative 9.8 times 3.6 squared over 2. I get negative 63.5, I think. Yeah. Now, again, if you asked me how far it fell, I wouldn't in English say negative 63.5 meters. I would just say 63.5 meters, but I'm not going to freak out if you leave the negative in there. It's a vector answer. We found the displacement good enough. Okay. Dropped. What's VI if it's dropped? 0. We're going to be doing a short lab now. It's going to be a little chaotic, but that's okay. I'll explain how it's going to work. What we're going to try and actually measure is A. We're going to see if we can measure that 9.8, because I've told you it. So let me pause the video for a second.